As an intro, I'm happy to have tonight with us at our third online workshop, Loris, from PDS Velebit, the speleological section from Croatia. And most of you already know Loris. He was at the Balkan Keepers Camp in Croatia, and he showed us an on-field demonstration which was really nice. And due to the high interest that we had, I asked him to join us again. And in today's presentation, Loris will introduce the principle behind LiDAR surveying and Gaussian splatting. The principles that he is in a huge challenge right now with. And I would like to say that this session is intended to be an introduction rather than a deep technical workshop. Because the good news is that after the vacation, sometimes in autumn, towards November maximum, we will have a more detailed workshop after Loris will have a bit of time to process all the data
I don't know what.
that he gathered. Okay. As you know, I will mention that the Balkan Speleological Union welcomes speakers from all over the world. So if you have a topic that you would like to share with us, or discoveries, or after all the expeditions that you're going to have in the next period, and if you want to share your results, we would be delighted to hear from you. So let me know, and we can work on organizing a workshop together. So that's about it. What I had to say. I'm happy to see this high interest in our event. And Loris, welcome. The floor is yours. So let's see what you prepared for us. You're on mute. The constant problem of
Yes.
Yeah.
Thank you for introduction. And this will be a short overview what I am doing last 20 years since I will share screen and little bit. I believe you see presentation, and what I want to say now, I'm celebrating 20 years of caving. I finished caving school 2006, and this is the best school I take in my life because I meet some great people, travel a lot with these people, caving a lot, and have great time. So at that time when I finished caving school, cavers use usually compass and clino and tape for measuring caves. So after that they use tandem compass and clino in one device, and usually they use disto instead of tape, but still this job was very time consuming, and people cavers don't like this very important part of exploring caves. So documenting caves is very important, but it's very time consuming and boring, and people don't like draw caves. So at that time, in 2008, I first time see paperless caving. Bit have great guy put some chip, and we have this Leica Disto A3 and put this chip inside, and I was very excited because this technology was very similar. Like I work on faculty of geodesy and teach student how to measure parcels, and this device was very similar to our total station, and I try to teach cavers in Croatia to use this Disto-X or similar device for paperless caving, but old cavers don't like this new technology. They say we are good with compass, it's okay for us, and their kids, young kids, they follow me, and they want to work with this Disto-X, and now these kids are great cavers also, and using Disto-X and similar devices. I I wrote an article about Disto-X. I tested with comparison with like with Sunto, Disto-X, and Total Station. So it was 2014 on one congress in Prague. I show this result. You can find on internet this paper, and also I have a chance to work with terrestrial laser scanner. In 2007, I first time worked with this scanner. Our faculty buy one. It was very expensive and big, but I see great potential with. I know at that time that LiDAR will be sensor for documenting caves in the future, and we use this technology for some caves, but it was too expensive. I think first cave we do is in 2016. In the beginning, we use these spheres for a reference. When we do static scan, we have station. We put scanner every 10 meters or similar, and to connect all these scans together, we use these targets or spheres. And when computer technology develop nowadays, we can use iterative closest point algorithm that will connect mathematically together these all scans. We need only rough alignment, and then computer will do fine alignment. So in 2016, we first scan Cerovačke caves, where we have Balkan's cave camp, and this was very difficult job. We have a lot of station, and this is more than 700 meters scan. I didn't put everything inside, only to see how it could look when we do laser scanning. In 2018, I think, we scan Cerovačke again, but this time I buy these flexible LED panels, and we use it to because we got the new scanner Faro with color with cameras, so we need light to get color of the cave. So you can see this is the same cave but different technology. And of course the biggest problem was light, because we need light to get real colors of the cave. So you can see when we put light, where is light, it's brightness. When we don't have light, it's darker. But you see how it could look if we use color. Then I think in 2023 or similar, we scanning Baracheva caves, and this time we use Leica BLK scanner, and this scanner has you see we use this target to georeference scans, and we also use camera, and we can measure on picture with this, but this software is like a register. This is very expensive software, and you can see we can measure temperature of the wall, because this scanner got infrared sensors, so thermal sensors, so we can measure even the temperature. So this is what I want to show you for static laser scanning. But what I see, I think it was 2014. I first time heard for SLAM, simultaneous localization and mapping, and I was very fascinated with this technology, because this first ZBD from Cicero company from Australia, it was funny. It moving on one spring, and it looked very funny, but this device is very efficient, and I was very excited that such technology exists, and I tried to use something like this, but in that time LiDARs are very expensive, so I couldn't afford to myself to use LiDAR, but there was a lot of different SLAM algorithms. Some of them work with LiDAR and some of them work with camera. So I buy in that time monocular camera, and try to use SLAM algorithms, free open source SLAM algorithms. I think I use LSD SLAM for Germany, and I get some result. It wasn't perfect result, but these results are promising for the future. Photogrammetry is very old. Photogrammetry is principle of photogrammetry are almost old like photos, because if you take photos from different angles and you have enough overlap between neighbor photos, you can get a three-dimensional model of this object you picture. So I think in 2014 we buy first drone on our faculty, and with that drone we get photogrammetry software, and I tried this software. I tried to do some photogrammetry in cave, but first time we use very poor light and didn't get any good result. Second time I borrow Scurion light, and this was I think in 2015, and this is my first photogrammetry result of one wall in the cave. It's not big, it's only I think 2 meter, but I saw that with good light I can get some decent results. So I think in 2016 with my diploma student Karlo Tkalec, we take more than 1,000 photos and get this Vindia cave. It's about 60 meters long or something like this, but we get pretty good result with only photogrammetry and bunch of photos. We have problem with floor, but we use total station and get some points, and so you can see this white are something what we done after, not with photogrammetry, but these results are good, but we use mostly daylight. Only in the end of the cave we use light which I buy, these LED panels, but this is very tedious job because we take a lot of time to collect these photos and very long time to gets these results. So I always have on my mind that we need to be efficient on the field. So first time I meet one guy, Marcel from Geoslam. He visited Croatia in 2018, and Geoslam is very good product, but his price is too big for cavers. So here you can see why I was so excited. You can use this backpack and use this technology and only walk through cave or everything what you need to document. So at that time we start one big caving project, and we buy one this Geoslam Zeb X Zeb Revo, and this was good, but usually caving clubs doesn't have such huge amount of money, so I wait for something that average caving club can afford. At that time, my assistant Anton Jakopec and I work a lot with free open source SLAM algorithms. We buy some Livox LiDAR, solid state LiDAR, Avia, and also after that we buy Livox Mid 360 and get some good result with HKU Mars. One, I think it's from Hong Kong University. They put a lot of free SLAM algorithms, and we try to prepare. When Marina asked me to do workshop on Balkan Cave Camp in Cerovačke, Anton and I prepare this Air3 Live SLAM system, but it was very, when all this SLAM system work on Linux, and Linux is very difficult to install hardware and ROS operating system, and this was everything too difficult for some average caver. So one big thing it happens when Anton suddenly found on YouTube a link for this guy Janusz Betkovsky, and it was a few months before Balkan Cave Camp, and this guy Janusz put something what we waiting for a long time. he put how you can build your SLAM system, and also he put free open source software which work on Windows, and it was very good software, but without almost any documentation. So we didn't know how to use this. I tried to build this hardware, and we have some problems, and we contact Janusz, and Janusz told us that he will be in Croatia for a few weeks. We meet with Janusz, and I like this guy. He's first time we saw, he answered all my question, and I asking him to come to visit Balkan Cave Camp, and he is accepted this invitation, and most of you, I believe, was on this Balkan Cave Camp, and we do some workshop, and I believe this is very good things. I don't see yet something similar to Janusz equipment. I built this. This is my first Mandai system. One LiDAR, Livox Mid 360, and one. This is controller and battery. This is all you need for start. And with this equipment, we get first results. I was very happy to see. I wasn't in that cave, but I explained my colleague how to collect data. Only push one button, walk, and with one LiDAR you can get good result, but sometimes you don't get floors if you need to bring LiDAR almost horizontal, and because of field of view, this LiDAR was Janusz told us that will be better if we use two LiDAR systems. So we buy another Livox Mid 360, and Janusz put also software, free software for combine these two LiDARs or more LiDARs. It's very easy to use software. Everything works on Windows. So after this result, I made another system with two LiDARs, and now we need to switch to get this internet 3-in-1. So with this LiDAR, we use it in one big cave. Almost we scan more than 1,000-meter wide cave, and this is only in one direction. So in before video we have two directions, to the end of the cave and back to the entrance, and now we scanning with two LiDARs only in one direction and get great result, because with one LiDAR we have problem in very tiny spaces, and with two LiDARs we have, you will see now we go inside one meander, and man can hardly pass through this meander, and we get these results. And I was very happy with this result, and I think that speleological community should know more about this Janusz software and use it more. And then I try another thing. I put 360 camera on that system, and now I try to do something like Gaussian splatting. First, we do some experiment in my faculty. we get good result. This is with daylight and only, I think, maybe 30 seconds of walking with 360 camera and this Monday system, and we get this result. After that, I was very happy with this result, and I try to do something like this, but in dark, complete dark. I use only my three flexible light LED panels and get results like this. And I was very happy, and I thought if I can get these results in complete dark, this will be great for caves. And then I have a lot of ideas how we can do this, but for now we didn't get any good result, because in this room we have white walls, and in cave walls are dark, and we don't have enough light. So I start to buy more light, and I will try something with moving. I try already with moving light to put light on myself and walk through the cave, but problems in that case are shadows. And I will show you, I don't have now, but I can show you what we got after. So this is a short presentation about what I'm doing in past 20 years, and in the future I will work definitely on LiDAR scanning and on Gaussian splatting, and combination of LiDAR and Gaussian splatting. So maybe this is all I prepare for this presentation, and only I can show you this result. This is Gaussian splat of one tunnel in front near in Zagreb. And we have, you can see, problem is with light. Some parts are too bright and some parts are too dark. So now I have planned for a few days go to one cave. I buy more light and I believe I can show you something better in the near future. So this is all this what I prepare. But now, if you have some questions or some your comments, I will be happy if I can answer.
I think we can stop the share.
Okay.
And everyone, you can start with your questions. You can either address them directly to Loris, or you can write them in the chat, and I will make sure that we will answer everything.
Oh, Tomasz Pawlowski, he's active in our group with Monday system. Hi.
Hi, hello.
Do you have maybe more experience than me? I see you are very active in a lot of caves using Monday system. I don't know, is there here anybody else from this group?
Yeah, hello everybody. Yes, I'm active, but I use only for surveying for caver. I don't need color because you work more than what I need. And we still working on group, yeah. We still don't have solved
Yes.
every problem. Yeah, I hope we meet on Croatia on the European.
Pazin, yes.
Yeah. Also, maybe on the Macedonia, we Balkan cable, we prepare something presentation or maybe some training with LiDAR. We show results because we have many interesting results, but more for cable and more. I am not so interesting. So 3D. I need after take data from LiDAR. I need a plan for cable. Yeah, it is for me more important. Yeah.
Yes, I work on that. That's what I talk with Emma before this presentation, because I think this is most important for cavers. Most of cavers will not use Gaussian. We don't need to use Gaussian splatting because I think it's very important to get floor plan and extended profile from LiDAR, and that could be next topic. I wrote one article about that in International Journal of Speleology, how to get these extended profiles and floor plan. But now I think this is old data. Now we have new data, and I think these things could be better. So I didn't have time to prepare this, but maybe for a few months I think it will be good topic to talk about how from this three-dimensional data to get two-dimensional data, which most of the cavers know how to use.
Yeah, it's true, but also 3D is extra and better than plan on profile.
Yes.
But files and big files, it's many giga files. It's problem for us, yeah. And if we have technology which we can see this 3D on the phone, I'm sure I prefer 3D because it's much precisely. But on this time, we don't have this technology and it's problem, yeah, and this is why. But
you can subsample the data, but I don't think the problem is in the data is too big, because now with some voxel or some other kind of data, you can watch very huge files. But the problem is what I talk, if you see with Janusz in the future. I think very important for us cavers is localization. That when we have, let's say, for a few years, we will have on our cell phones, we will have LiDAR, and we can do three-dimensional data with our phone. So if we have our 3D model on our phone, we need to be able to locate ourselves in this 3D model. So then we can use only 3D model, but not because there is some other problems. When you want to prepare expedition, you need to know how much rope you need, and that's. I think it's okay to have floor plan or plane or extended profile of cave even in the future, but some kind combination between LiDAR three-dimensional model and two-dimensional model, this is something on what we need to work. I work, but I don't have much time. I have a lot of obligations, so I think for a few months I will have more time, and I will time to do stuff in that direction.
Exactly. If some people have, if you have time, everybody, I can show some results 3D. Yeah, because we cooperated with some platform which is very expensive, but we have some education, I don't know, license. Yeah, it's much cheaper. Yeah. And we working and now it's possibility take to phone results 3D, but still we working and we cooperated with this platform to made some how to say compressed these files will be much faster and much easier look at on the phone. Yeah, and this is very interesting. If I have option to show, I can show some small results how looks this. I don't know how I can
Share
moment
screen.
On the
share this.
bottom screen, you have a share button, Thomas.
Up right.
Yeah, I see. Okay, okno, a window. Okay. There is Atis Cloud. It's very expensive in my opinion, but it's very nice platform which can show some presentation. Also more cheaper. It's completely free. It's pottery, but it's a little bit complicated and a little bit slowly. We're working on the pottery in many countries with work. Example, this is cave Mesiat. We don't finish, but we this cave we comparing. I don't know. You see this? I hope.
Yes, yes.
We comparing many methods surveying. Also, disto, brick, cave wave. This new device after disto. Faro and many others LiDARs we comparing Cavetron and we have many information about moment I will turn off some not necessary and I show you there is surface also we made surface, yeah, but it's not necessary here, yeah, and we can comparing how looks our LiDAR with plan which made many years ago. I don't know which techniques it was, disto one, but it was not so precisely, yeah, because you see many places it's different, and we check this. We check this also tachymetry geodesy instrument very precisely, and our Monday, our Faro focus and other LiDAR Cavetron, it's similar, and all map it's you see how different it's completely different shape corridor sometimes place where is this corridor not exactly on the same place. It's many mistakes on the old plan, to be honest. I believe that it's not because people made this mistake special, because it's very hard surveying. All which people which surveying know about this. Yeah. Okay, doesn't matter. I show you this project example last time in the Bulgaria. We made after 3 hours around 2 kilometers cave, which is very complicated. When I starting surveying on the first time, I think probably I can do it because it's really like labyrinth. A lot of left, right, many levels. We need a rope, yeah, a lot of water, yeah, and we have results on the 3D. Really exactly which are surveying also before disto, and it's only one mistake because we have still problem with artificial channel like mine. Yeah, this is artificial channel which people digging to take water with cave, and this artificial it's not correct. There is some results about banana drift, yeah, and we have half meter mistake, yeah. Janusz work with this. I hope will be some solve this problem with artificial. But for us, caver is not important artificial. For us, it's important all which we surveying with on the cave. If you see how complicated this cave is, many like labyrinth, and all what I surveying, I only walking 3 hours walking. Less than 2 kilometers cave, but with 3 hours walking, don't doing nothing. And after 3 hours walking, after 5 hours processing on the cave, I have these results. Yeah, of course it's 3D for 2D for plan and extension profile. It's no problem. It's 20 minutes for me. Made plan. Maybe not precisely like made on the plan every information, where is water, mud, but it's not important for good caver. Important is direction and corridor. Yeah, you see how it's very, very easy. Also, we work big project in the Tatra on the big cave. It's really deep and big cave, but this we working on the pottery. But I hope on the Croatia we show result and some interesting. Yeah, now we're still working because it's a lot of work. To be honest, not so many people help because many people don't believe it on this technology. A little bit scared. I remember 20 years ago when starting this, that was the same situation.
Yes,
People
also.
say, yeah, tape, bussola and inclinometer, not this. It was after 5 maybe years start using this stocks. Yeah, it was the same. It is. I think it's the same situation now. People a little bit afraid, but when he see results are start thinking it is really future, and soon will be ready to completely working on with this. Yeah, I think we will see how will be. Yeah.
This
okay,
is very,
that's all, I think.
very impressive. You don't georeference this data with this huge cave labyrinth you show us. You only walk, and this is only LiDAR odometry.
Yes, yes, this is only LiDAR odometry. We have a georeference, like we made some GNS RTK 3 points on the entrance, and we have very precisely 3 points, like 1 centimeter precision. And
this is only orientation.
Yeah, orientation for orientation and localization, but inside only SLAM, only Janusz software and nothing more, really.
And you use double LiDAR. This is important.
Of course, double
because
LiDAR.
In this very tiny spaces, we have problem with one LiDAR. So this is important. So I'm happy that you share this data and to people see how it could be efficient and precise, this measurement. It's great
I
to
hope
see
we together show more on the Croatia or maybe on Macedonia. We will see how will be time to preparing something good.
Yes.
Thank you.
Really nice. Anyone has questions? Any other questions?
Yeah, hello.
Hi.
My name is Radovan, and I'm pretty new to this topic, but we are like preparing for building one LiDAR. And the one thing I didn't get, I'm trying to understand, is your device built like with a processor unit doing SLAM, or you are doing SLAM after you have input in your computer?
We only collect data with this Monday system. All data was saved on one USB. You put this USB from your LiDAR system, put it in your computer, and you have exe files. First thing is LiDAR odometry. You put data in the software and wait, depends how much data you have. Every 10 seconds is one file. So if you have a lot of files, it could take, let's say, I don't know, usually if you walk 10 minutes, depends about your computer. Let's say you have 10 minutes of data processing time. Let's say maybe 20 minutes of data processing if you have so slow computer.
Yeah, I understand that, but in some article somewhere I wrote that it's possible to like implement slamming directly into the processing unit.
It is possible. It is possible, but Janusz told us that this is possible with 5. I use for B computer. How help me, Tomasz. Computer unit is
Raspberry Pi 4.
Raspberry Pi.
And
Yes, I use 4B, and Janusz told if you use 5, that you can do LiDAR odometry in real time. I didn't try this, but probably it is possible.
Why I'm asking that is because in that same article I wrote that will prevent like many mistakes that LiDAR make.
No, I don't think. Maybe they will not prevent mistake, because if you have mistake, you will have mistake. But on that way, you can see online in the real time. You can see if something get wrong. If you are aware of where you walking and you see what you got, so you can see the error. But if your system have some drift, your data will be collected with this drift.
Okay, thank you very much.
But you can do, Janusz put something to detect these problems. One part of his software is to combine IMU results and odometry, LiDAR odometry results, and if these are disconnected too much, you can see where this happened. So if it is possible to put out this data and connect again, but I have problem. But if you use double LiDAR, these problems are less. You have less problem, but if you have only one LiDAR, I have a lot of this problem when I use monocular camera, because when you do rapid rotation, your SLAM will lose, get error in results. So, but with LiDAR is better, but you still need to be to walk slow, especially in narrow parts, and there is some parts where these problems occur, especially in like Tomasz said, in some tunnels or something which is similar. In caves, we don't have a lot of this problem, because caves are very a lot of diversities. It's not the same. If you have always the same structure, SLAM have problem, because he needs some characteristic point on terrain to reference to locate himself in the space.
Okay,
but
thank you very much.
It's good. You are on good way to work your system. I'm happy to hear, because now it's problem with Livox Mid 360. I don't think they're usually not in stock, so you cannot buy it easy. I don't know how you buy. Did you buy Livox Mid 360, or you didn't buy it yet?
I did not, but we will figure it out.
Okay.
Hello. I have this experience with the Livox 360, of buying it, you have to watch the website from DJI for because sometimes it's a piece of hardware that is bought a lot because it's used in automotive, and it's for for 2 or 3 months. I couldn't buy it. It was like a year ago, and you have to watch it frequently. And sometimes you can buy it, but from a different country, because they have in Europe big depot, and in some places it is available because you have stores per each country. And usually from DJI is the cheapest and the best, not to buy it from some Chinese other. Just my personal experience, if it helps someone.
We also buy from DJI, but a lot. I have it, I don't look, but when my friends ask me, and whenever I look, it was out of stock. So I saw that they produce some new, Livox Mi 360S. I don't know. Janusz say that he will try this data, get data with this. He order, but I don't know. In group, he didn't put any results now, not yet. Do you know maybe something more, Tomasz?
No, not ready. If I think it's not ready.
Yes. It is a big problem because I watch solid state LiDAR till 2016. First time I hear for solid state LiDAR, and they claim for 1 year that solid state LiDAR will cost €200, and I wait 10 years now, and nothing changed much. There is not so many good lidars and cheap lidars on the market. 10 years after this, claiming that it will be very cheap, very small, very everybody will use it. There is a lot of startup companies. They produce prototypes, but then auto industry start to buying these lidars, and I don't know. I think everything goes much slower than I expected.
I will say something about mistake because it's very important. Mistake surveying. It's a very possibility, but if you have some methodology about surveying, in my opinion, it's very hard to make mistake. Especially we surveying all cave 2 times. One times if we're going on the one side, and when we go back, we have second times. If I have the same surveying, if I have the same results after SLAM, it's
You
like
believe?
Yes, it's easy. Of course, on my 10 cave, sometimes 1 or 2 can be some mistake. I need repeat, yeah, because or I can found this mistake and I can working, but it's much harder sometimes found and working than going and surveying one more, especially if we visit or we exploring this cave. Yeah, it's no problem. Last time, if we going some deep and long cave, we take 2 LiDAR and we have 4 surveying. Yeah, more chance to have the same results. Yeah, it is much easier. Yeah.
Yes, and you use very good equipment. You have some tripod for leveling. Wait a second, sir. You inspired me to do something with 3D print. I buy a little levels, bubble level, and do all this 3D printing part to put my system to be leveled, because I think it's pretty important that we have a level system from time to time.
I think it's very, very important, because if some will be some mistake, some error, if we have many this leveling place, we very easy can find this mistake, and very easy we can repair. It is my experience about this, and I am sure I show on the presentation on the Croatia, I hope, or Macedonia information about, and we training, we will see how to looks. Also now on the Craig Journal in the England, it's our article with Janusz about this, and this is many information. It's can you read, and on the GitHub, yes, also many movie about this surviving. It's much easier, yeah.
Yes.
I have one more question. So, congratulations, Loris, for the presentation. It was a very nice overview of the history of 3D mapping. Regarding the camera you put, what camera you used for on the LiDAR?
I use Insta360 RS 1-inch camera. It's pretty expensive, but I think Janusz use X5. It's cheaper. I think our camera cost 900 euro, and X5 cost maybe 500 euro. I'm not sure about this, but it's I do a lot of time spent to do some Python script to get results. Because with this camera, it is important to have delay. How because this camera and this LiDAR are not connected, software connected like in computer. If you put some wire, you can measure exact time and synchronize camera and LiDAR. But now we need to do some different kind of computing delay between camera and LiDAR. And LiDAR has a lot of information, 200 hertz to 200 data in second. And the camera use usually 24 picture per second. And I realize I do some script. I use photogrammetry to get extrinsic parameters to compute how my camera was far from center of LiDAR system, to get 3 translation and 3 rotation data. And when I know that, so I can use LiDAR trajectory to get camera trajectory. And if I know delay, I know coordinate from some specific time moment, coordinate for camera, and yeah, I use these coordinates for input for like input for photogrammetry or for Gaussian splatting. So this is something what I do last few months. And also Janusz have some guy, this is great guy, help me, Tomasz, who do also something like I do, but much better. Michael Pelka, I think. Michael Pelka. He put also some free software for that, but there is a lot of possibilities to compute this delay. I empirically know that when I push button for continuous scanning, I first see a green light, then I see red light. When this red light first start, I see how much time passed from start recording video till this red lamp. This is, let's say, beginning value for measuring delay. And then I use data from LiDAR odometry. So I know when let's say if I put a LiDAR system on this tripod and he's leveled, I put it 30 seconds, and when I take up this LiDAR system, I will record on the video this movement, and also I will have data from IMU to see that this movement happened. And this I put in ChatGPT. I do some Python script to measure fine delay, and then I use this delay to calculate position of camera. So this is basically that what you need. But when you talk about that, it's easy. But when you try to achieve that, it is a little bit complicated, because there is. It depends how fast you walking. If you walk very fast and your delay is not very correct, so you will have wrong coordinate. We can talk about this a lot. Maybe it's a question for one workshop, but for this workshop, I will be prepared maybe for half year. Now I think it's better to talk about LiDAR and how from LiDAR data to get map or to the dimensional maps. I will prepare this, I think, for Pazin. If I have time, I believe in Pazin, I will talk about this topic.
Yeah, so basically you're doing a manual alignment of the video with the data at this point.
Michael Pelka also put some things with light. I can show you. I buy this. This is very cheap. This is this LED light and small, like little computer. It's very cheap. Everything is cheap, but I didn't get good result with that. This could be better, but it's. You see, you got these wires in cave. It's not so easy. Maybe it's better to manual compute delay, but I see this color isn't important for most of the caving stuff. Color is very difficult because you need good light, a lot of light. There is some few days ago, one guy put something on group Monday. You can see this is how it could look, and that's something what I like to achieve. This is a combination of photogrammetry and Gaussian splat. You see, most of the cave is Gaussian splat, and these parts are photogrammetry. Photogrammetry
I think you're
is...
not sharing if you're
sorry,
showing
sorry,
something.
sorry. Thank you for saying. This. Yeah. You can see this is Gaussian splat, and this is photogrammetry. Only photogrammetry is bigger. Yeah, you see now or not?
I cannot see it. Maybe. Do you see it? Someone else?
Sorry. What I am share.
Yeah, now it's working.
Now, you can see this is Gaussian splat of cave, and this small part is photogrammetry. Photogrammetry is about 10 times bigger than Gaussian splat. Gaussian splat is very light, so you can render it very easy with your phone. If you are interested, you can type in your browser. You can type super splat. Wait a sec. You type super splat, and you have a lot of Gaussian splat examples. So you can see it's very easy to load. This is all on the internet, and you can see how it could look. It could look great, but this is in good condition. If you have, now I will take control so you can see this is all, it look like video, but this is all three-dimensional. It's not like point cloud. It's like these spheres which are stretch. You need to train. This is also great because there is a lot of free software for Gaussian splatting, and you don't need to pay. I start with post shot and I get good result, but when I try to export this result, they told me that I need to pay. So I try to figure out does it have some free software. I try INRIA. This is original INRIA. I think they publish article in 2023. And this is new technology, but there is a lot of free Gaussian splatting softwares. You can use a lot of different open source software, but problem is with Gaussian splatting that you need a very good graphic card. So in the beginning I have a decent graphic card, but when I put let's say 400 pictures in my computer, it took me 2.5 days to training to 30,000 let's say you can put intervals to train, so you can start 7,000, 30,000 is optimal, let's say, and on my computer it took 2.5 days. So I ask permission to connect to supercomputer at our university, and now with this supercomputer I can do this for 20 minutes. So, but this computer have 200 gigabyte RAM, and what is very important, this computer have 40 gigabyte VRAM. This is RAM for graphic card. So this is problem with Gaussian splatting, and that's why I think it's not important that a lot of cameras do Gaussian splat, but it's important that a lot of cameras use LiDAR technology because it could significantly do better job in for less time.
Yeah. Thanks for the answer.
Any other questions? Okay, then. So thank you all for attending, and Loris, thank you very, very much for having this workshop for the Balkan Biological Union. And we meet again in autumn.
Thank you. We will hear. I will say when I will be prepared, so then we can arrange something.
Yes.
I believe for beginning it could be a better topic to use LiDAR and how from LiDAR data to get two-dimensional map of cave.
Okay, that would be great.
Thank you,
So,
everybody.
Thank you, and see you all soon. Bye-bye. Bye.